Hi, I'm Alison Keogh, CEO of CEEC. Our organisation helps accelerate eco-efficient minerals, and you're listening to our Spotlight Leader Conversations. Our communications lead, Ailbhe Goodbody from Montreal, talks with Paul Shelley, Global Vice President of Innovation for Molycop. Molycop is an organisation that has some really innovative products, and they concentrate on high breakage resistance and low consumption rates in mineral processing plants. Enjoy.
Today, I'm delighted to be talking to Dr. Paul Shelley, Global Vice President Innovation at Molycop. Paul is a real champion of CEEC and a mentor for people in the sector who's at the forefront of innovation in grinding. He's also a strong advocate for both innovation and collaboration, who's passionate about mining, accelerating energy efficiency and digital enablers. He's Oz industry expert in the Australian government's Accelerating Commercialisation Initiative. Together with his team and Westgold Resources, he received a high commendation technical research from CEEC on a paper titled SAG Mill Optimization Insights by Measuring Inside the Mill. So Paul, it's great to have you with us here today.
No problem.
So with COP26, there's now a keen focus by investors on net zero. What is Molycop doing in this area, and what are your thoughts on industry opportunities in this area?
I think there was investor focus on net zero and ESG prior to COP26. And I think that when investors talk, the miners pay attention. So, I think that we have been working on ESG for some time with the knowledge that we have to address the environmental, social and fiscal aspects of our customers. So we are working on three pillars that form our ESG strategy. One pillar is demonstrating shared commitment with all our stakeholders. The other one, solving problems that our customers are trying to solve. And the third one is creating social value. Our current specific initiatives include reducing emissions, waste reduction, participating in the circular economy, improving the energy efficiency of the grinding process, and building stronger communities in which we work. Some of the examples: in 2020-2021, we have already performed a detailed study of our greenhouse gas emissions right across our global footprint, and we've benchmarked that, and that allows us to identify opportunities. We've analysed emissions between our Australian electric arc furnace operation and international basic oxygen furnace steel making, so that we can differentiate our offer right across all of our markets. We're collaborating with various universities, including the Sydney University, to reduce the energy efficiency of comminution. We have an ambitious plan to try and halve the wasted energy of the SAG mill. We've implemented a 100,000 megawatt per year long-term power purchase agreement in Australia, which is backed by local solar and wind farms, so green energy provision. At Molycop's La Joya plant in Peru, where water is incredibly scarce and must be transported by tank trucks, we invested to combine dry cooling and heat exchange with water treatment facilities to recycle wastewater. This permanently reduced the water consumption at the site by 82%.
Oh, wow.
We also, in our mergers and acquisitions platform, acquired an Australian regional recycler to support direct scrap sourcing and establish a circular economy by solving customer waste challenges. And if you go on site, you can visit these initiatives in our Molycop 360 platform.
Do you think that there's a role for CEEC to help collaborate on solutions across industry?
Yeah, we believe CEEC, its members, its associate and its network are the industry leaders in collecting and communicating efforts to reduce energy and water in mineral processing. we don't think anyone's doing it as well as CEEC. The communications and forums provided by CEEC are critically important to our deliberate work in scanning the industry for innovation and separately marking to market our ESG initiatives. We feel interaction with CEEC builds our ESG gravitas.
So we know that comminution is key to energy efficiency and productivity. What do you think is the impact of new technologies in this area, and how do you think we can reduce emissions and the consumption of energy and water?
Yes, the impact of new technologies and innovation is significant and transformational. The impact of the digital transformation has resulted in significant and fundamental change to the efficiency and productivity of comminution. We feel the miners and suppliers have reached the adolescent stage of value proposition development. The industry have moved past the buzzword stage where everyone was, racing around in conversations, yelling out big data. Now I think that real value is now being created by players that were probably not previously on the mining supplier radar. Players like the data analytics, the physicists, the mathematicians, those types of people. There is considerable industry appetite for data capture, analysis and visibility now. The results are changing and challenging the heritage engineering fundamentals. Processes such as root cause analysis and/or reliability-centered maintenance dynamics are fundamentally changing within the digital world. There's a fast-paced move from point-in-time analysis to dynamic and real-time resolution of operating variability, and the development of cost-effective green energy technology is also making its mark. And as we've said, Molycop's participating in that. And technology advancements in this space are resulting in significantly reduced dependence on fossil fuel energy supply.
And what are you the most excited about in this area?
So we're probably most excited where we're actively participating. A little bit selfish. But in our view, we're playing a lead role in this industry dynamic. Our Project 86, which is P86 SAG mill sensor system, is already an industry breakthrough. So no one else can use sensors to measure inside a mill. And CEEC recognised this in 2019, awarding us a high commendation for that research project. We were very motivated by that recognition. As we said, we feel CEEC builds gravitas within our company. We're successfully capturing now and analysing the data from inside the operating SAG mills of the world. And we're only at the beginning of the inside of this project. And this will provide significant energy efficient comminution changes. With this project, we can validate load charge dynamic modelling, tools such as DEM. We can already see a comminution profile in real time. And we're continuing to research manipulation of the energy efficient profile such that energy supplied to the SAG mill is multiple times more effective than the recent past. The whole digital transformation and working in that space is really exciting to us.
So what do you think is the future of mineral processing, in the near future, by 2030, by 2050?
So I might start with the current state. And so if we just think about what the current state of mineral processing is, mineral processing circuits like a linear succession of plant and equipment nodes connected by particle streams. So a blast, a crusher, a SAG, a ball mill, a cyclone cluster, a pebble circuit return, flotation or leach cells. So all of these plant and equipment nodes, and they're all connected by particle streams. There's enormous variability, inconsistency, and inefficiency that exists within each node and within the particle streams and how they get to each node. Particle streams between nodes are mostly unmeasured. and really poorly specified as inputs or outputs. Modelling of nodes and the node connecting the stream is done in point of time, really, and it ignores the dynamic nature of the processes being studied. And it's very deliberately simplified to cope with the complications of the process. So a lot of the model fundamentals that are used are decades old, they're empirically based, and they struggle to be validated in the dynamic situation of the plant. And so if you consider that, we think the future of mineral processing lies in harnessing the digital transformation to produce a controlled, well-specified, low variability processing chain that is modelled in real time. Now, if we can do that, then the outcomes will be significantly improved energy use and energy efficiency, significantly reduced water consumption, improved throughput and recovery, the reduction of extraordinary wear events, and thus the reduction of wear consumables supplied to the industry. It'll facilitate continuous improvement and a circle of improvement not possible at this time. It'll drive down conversion costs. It'll reduce mining footprints. It'll change the mineral processing operator skill set, and it'll facilitate robotics, automation, and remote operating centres, the style of which we're seeing in the drill and blast phase of mining that has not yet spilled over into mineral processing, but the future is here soon, and those elements are coming. In the immediate future, the industry is going to build a roadmap for the circuit of the future, and it'll understand the technology required and when it's likely to be deployed. And the industry is building that now. CEEC is participating in building that roadmap. By 2030, circuits will be changing as a result of increased specification, measurement, and reduced variability. By 2050, leaders in the industry will have replicated plants we are more used to seeing in manufacturing or oil and gas. In other words, a really controlled environment with highly specified inputs and outputs. It's likely mineral content in the particle stream between equipment nodes will be well known. With the technology we've got, we'll know exactly what is waste and what's not waste and what will be processed. Variability within the circuit will be low, and industry leaders will be benefiting from the outcome previously described. The carbon footprint and the energy footprint of sites will be significantly less. The water usage and water wasted will be, significantly less. So that's what we see as of the future in those time windows.
And what's your vision for potential opportunities in the future of industry?
I think all industry players have the opportunity to participate in and create this roadmap. I think it's fluid, it's dynamic, but if you've got particular core capabilities and to drive innovation, and if you can align that with this digital transformation, it'll be a key enabler. I think paying attention to energy, water, and social outcomes will be the beacons for this change process. We talked about that at the start of the interview. If investors want and are paying attention to energy, water, and social outcomes, then they'll be the beacons for the change. It won't be accepted that the SAG mill is as efficient as it is today. It's just not acceptable. There'll be leaders and there'll be laggers, I think. With the pace of technology change we're now seeing, I propose leading is the desirable position. That's the strategy we're taking forward as Molycop. This will necessarily involve calculated risk-taking in a really conservative industry. I think that dynamic will change, but the rewards will be considerable. Working in the heritage-style silos that we've seen with high barriers to intellectual property and information share may not give us great success. We think that dynamic will change. It's more likely that collaboration, knowledge share, and embracing startups might be of great benefit And we think that trend will continue, is growing and will continue to grow in the dynamics of the industry of the future. We believe CEEC is going to be a really important and influential intelligence hub as the roadmap gets built.
So could you share your thoughts on CEEC and potential value and opportunities you see? For example, maybe new ideas for collaborative projects?
As we said, the network that CEEC has, the platform that it's established in recent years, the ambitions of CEEC are critically important to this change in the mining industry. We have a lot of time for CEEC. We think it'll be a really strong hub for knowledge share, for innovation, ideation type initiatives. A real centre for professional conversations that can help drive the industry in the direction that we talked about. I mean, we like CEEC, and we like its recent past. We can see the runs on the board. I think we'll continue to support CEEC.
Could you share some more detail on some of Molycop's recent initiatives? For example, your work on innovation of sensors and grinding balls and the opportunities to couple that with AI and optimization.
Yeah, sure. I'd expand on the Project 86, P86 project. So what we've been able to do is put sensors inside grinding media and put sensors on the shell of the mill and collect data from within the mill and from outside the mill. And we've created new industry variables as a result. So there's no one else measuring a SAG mill in operation as it's operating. And so what you end up with is new process variables. And so analysing those process variables using tools such as machine learning and artificial intelligence is new ground for the industry. The other space that this will be incredibly important is it's going to help mathematical modelling of the dynamics of the mill. So at this time, discrete element method modelling is the go-to tool for analysing charge dynamics within the mill, predicting trajectories, predicting energy transfers within zones in the mill. And this tool is constrained in the way that it models. So it's not a reflection of the actual dynamics of the mill. One of the key areas is invalidation. So it doesn't have data to validate the model that it's developed. So no one can actually tell if the outcome of that model has any connection with reality or not. Now we have the data. So we are working with a couple of universities, the Western Australian School of Mines, Curtin University, and SciGEM's facility at the University of Sydney. And we're connecting the data to DEM modelling, and we will validate or have the ability to validate the various models of the discrete element method modelling for the industry. And then we'll pitch a graphic on a dashboard to show in real time the dynamics of the load of the mill. And if we can pitch a graphic and understand the modelling and the data, we can manipulate the comminution zone, or the zone that's producing the product, the required product out of the SAG mill. And so that's got enormous implications on the effective use of energy of the SAG mill. We'll also be able to reduce extraordinary wear events. So what are they? So in wear within a SAG mill, there's routine wear, which is going to happen because of the abrasive nature of the ores, and they're running against essentially steel or iron products. And then there's extraordinary wear events where the cascading and cataracting nature of the mill puts steel on steel. So balls on balls or balls on liners, these types of things. So if we reduce the variability, we'll reduce extraordinary wear, and we'll be able to reduce the consumption of consumables within the mill. So imagine the the energy value chain changes if we're able to do that. Mm-hmm. We're able to reduce their weight, understand the wear dynamics, because we can see inside the mill. So we think it's a really important breakthrough. We know it's industry leading. We're only at the beginning. we're at the very start. It's already very effective. So yeah, that's a really exciting project for us. And of course, we have other. We went through a host of ES&G projects that we're working on within Molycop, including the reduction of water, Molycop 360, which is the circular economy, waste to energy type initiatives. So, and we gave examples of those. So we, working very, very hard at Molycop for changing the dynamics of the industry in terms of energy, water and waste and the social outcomes.
Paul, thank you so much for your great insights today. I appreciate it. And it's great to hear the work that Molycop is doing.
There's no problem at all. Always a pleasure to talk to CEEC.
If you've enjoyed today's conversation, get in contact, contribute your work and join CEEC's followers. You can tap into free articles, join our events online or in person, and watch and share future podcasts, videos and webinars. A big thanks to our valued sponsors and visionary volunteers, including our guests who we're interviewing, who make our work, our not-for-profit work, possible to help accelerate eco-efficient minerals. Thank you.